Welcome back to BSA by Design. I'm your host, Brian Moore. BSA by Design is a podcast about transforming healthcare, educational, and research facilities through expert design and insight. In this episode, I'll be talking with Marija Gumienny about technology and how it affects engineering and planning and design in the healthcare industry. It's a fun and robust conversation on all the different impacts technology can have on the built environment. But first, let me introduce our guest. Marija Gumienny is an electrical engineer at BSA Life Structures and is based in our Tampa studio. She is a licensed professional and has a BS in electrical engineering, a graduate certificate in technology management, and a Master of Science in engineering management, all from the University of South Florida. Thank you for joining me on the show, Marija.
Thank you, Brian. It's a pleasure to be here.
Well, like I like to do with all of our guests as kind of a first question, can you share a little bit of background on yourself? How did you become interested in engineering? I'd love to have you share that story a little bit.
Well, becoming an engineer was pretty much unavoidable for me. It was in my blood. It was all I knew. I was raised in a family of engineers in Russia. Both of my parents have master's degree in engineering. Father is still teaching engineering grad students at the state university. And
Wow.
My mom worked for a very long time at the factory as an engineer and then later on as an industrial process automation specialist. That's when computers were taking over manual labor, so computers were huge. They took space of the entire room and were programmed using these punch cards. Remember those?
Yes, I do.
Yeah, I had tons of them at home. My brother and I, we used to actually play with them all the time at my house. My brother actually is also an engineer too. He got his PhD in electrical engineering many years ago. So it was very normal for me. It was very casual conversation, even at the dinner time, to talk about math or circuit boards or radio antennas or computers or it may sound very strange, for the normal family, but when you have your whole family, parents and your brother, even my grandma, at one point, she used to work building airplanes and pulling cables in those airplanes. So, it was very normal, even when my parents were talking about their day at work, it was always something related to engineering. It was always something about systems or something happens.
Wow.
So, I grew up with it. Plus,
That's really cool.
yeah. And plus, I always liked math. I liked science. I liked problem solving. I was really good at it. Even when I went to School of Music, I played piano since I was 5. So I spent 8 years getting my music education. Somehow I just managed to find those patterns in a rhythm or count how many tones the two notes are apart, or it really helped me to pass all my music theory and all, but I found math everywhere. When I was in the 7th grade at my school, they split our class into 3 groups. One of them was something about finance and accounting. I wasn't really into it. Second one was, literature, languages, philosophy, history. And I'm like, wow, books, just not my thing. Too much time. Textbooks, yes. Literature and all, I'll get a short version of that, like War and Peace.
Right.
So at that time, I chose math and science major, and it kind of just started my whole path, in the technical field. At one point, I did think about becoming an architect, but so kind of being in this industry and working with architects now, it's kind of very, very close to me and to my interests. But I faced some challenges, and I just never pursued that dream. So I kind of switched back to engineering. So here I am.
I loved how you drew the parallel with music and counting and the musical notes on the piano and everything. That's really neat.
Yeah.
My daughter, who's 8, just started taking lessons, and I might use that because she's really good with math too. So
yeah, not a lot of people think of music as something really, exact technical science or thinking of more of artistic major, but there is a lot of math. There are notes.
Yeah.
There are a lot to it. So,
well, let's turn our attention to why I brought you on the podcast today, and that was to talk about technology And let me start with this. What does technology mean in the realm of engineering?
If we look specifically at the construction industry that we are in, because, as you know, engineering is such broad major, it covers all kind of industries and areas. So if we talk specifically about construction, there are different types of engineering here, right? So systems engineering, where most of us immediately think of electrical, mechanical systems here, right? There's also industrial and civil engineering and structural engineering, for example. So technology is just really a narrow area. It's a specialty, part of the electrical engineering field that focuses on communication systems, such as IT network infrastructure, building security systems, audiovisual systems, clinical systems, and many, many other low voltage systems. So for a long time, it was looked at as just like sub-discipline of electrical field, but with the number of systems now and, importance of the building network systems, it's really just a fifth discipline in an engineering for the building systems now.
What are some of the service lines then that BSA provides in this area of technology?
Well, at BSA, we provide full technology services. We have our CDDs in-house. We have many engineers. So we are able to provide full services for our clients for all three markets that we cover. So these services include technology, systems planning and design, vendors evaluation, systems product selection, construction administration. We do post-occupancy evaluation about a year after the building is built to see how it goes and what the outcomes are from the solutions that we came up with. And of course, code study and pure consulting services, for mentorship, advisory, or the peer review.
When you do that testing, does that help inform what you guys might do in a future project?
Definitely, yes.
Post-occupancy?
Exactly. Yeah. It's one of the reasons why we do it, to see how design relates to the outcome and collect that data and incorporate into the next future project. We always look for the continuous improvement, to make the design lean, to eliminate that waste, or if something is not needed or something actually doesn't work like we designed it in theory. So that's the purpose of the post-occupancy evaluation of the systems, and also see, where we were with capacity and expansion and help our clients to do the vision casting and plan for future.
We're not just putting it in and then walking away and never looking at it again, right?
Exactly.
Yeah. Let's talk a little bit specifically about low voltage. Can you talk about the importance of low voltage systems in modern healthcare buildings and what some of the challenges are in designing and implementing low voltage systems?
Oh, healthcare. That's my favorite topic. I can talk about it all day. There's so many low voltage systems in modern hospitals now, and that's what makes every project fun every time. I'll start with the fact that in the hospital, remember, that's the facility that runs 24/7. All the low voltage and communication systems are not just important, they're critical for the life safety of both patients and people who work at and visit the hospital, whether it's nurse call system or security devices or first responder radio system. They're all directly related to safety of people that are inside of facility. And, we pay close attention and we must design that very carefully. Besides hospitals, they operate in emergency settings too. So it's very important to have that reliable communication with other facilities, for example, during emergencies, or be able to monitor weather during natural disasters, or keep communication going with EMS, your ambulances, your helicopters, in order to take new patients or to transfer patients to another hospital, or just simply get supplies. Because with emergency settings, there's a whole plan of emergency preparedness, and communication systems play a big role in that. So low voltage systems are very important just to get that operation going for the healthcare facilities, and not just hospitals. Like that includes outpatient facilities too. So it's critical. Okay. Now let me talk about challenges a little bit. So
yeah, please.
So besides challenges that are kind of common with other disciplines that we face on the technology side, such as physical location of the project, for example. As you know, different states follow different codes editions, and different local AHJs may have different expectations about how systems shall be designed or perform or function, because there is a little bit of gray area, and some of the responsibility and decisions fall on a local AHJ. So that's kind of like a common challenge for engineering altogether, to keep up with all these codes additions and changes in the systems requirement. But what we face on a low voltage side, there's another layer of difficulty, because almost all of the systems now are integrated. So they talk to each other or somehow interfaced with each other, meaning that we're not looking at the design and design just a system by itself. We define the system requirements based on what other systems we have in a building, what those other systems are capable of, and what they're used for. So that integration piece is not found in a code. It's not in a book. It's not guided by industry. Right. It's not spelled out very clearly for you. Like, it's unique to each facility. It's unique to each client. It's something that is designed by technology engineer. It simply depends on the needs of the hospital, on its operations, on the priorities. But, that's what takes a lot of time and effort, to carefully evaluate each system to make sure that integrated solution as a whole provides all the functions that are needed, but at the same time, we don't have gaps in performance and we don't have overlaps in functionality, because we're still trying to build a cost-effective solution. So that's that extra layer of difficulty and a challenge that, I feel like other disciplines like mechanical or electrical doesn't really face, because systems are interconnected, but not to the degree how we deal with technology systems. Plus, technology systems are always changing, always improving. Technology just on its own is just such a fast-paced industry.
Evolving every day, right?
Every day something new. That's why one of the reasons why I love doing technology design, compared to electrical. By the time when you design one hospital, there could be so many upgrades or even like new innovations or new systems and new products on the market. Like, you can never copy design that you just finished into the next project. So As soon as you think that you got it, you know it all, yes, let's go, and then it changes all over again. So, those new innovations and technological breaks create kind of like a never-ending learning curve for technology designers. Like, we always have to attend webinars, keep up with vendors and new products on the markets, and then how different manufacturers and systems integrate with each other and what kind of information they send to each other and how we all process it. So that's kind of also additional challenge for us, because we're moving really fast in this technological world, trying to find solutions that benefit and, satisfy all the needs of our clients and facilities. So, and
that makes a lot of sense.
Like with this speed of change, like I see even codes sometimes can't keep up because they update them every 3 years. And sometimes there's already new systems and new technology, but yet we're going by older codes. And I'm like, yeah, I'm not sure, but like, let's do this. And then we'll just figure it out with inspectors as we build it. There are more and more new paragraphs reserved for different systems in the code book because they know it's coming, but yet they didn't define those specific requirements yet. Those sections are still reserved. Another challenge that it's not just black and white. And finally, I want to note that the increase of the use of personal devices, wearable technology, more and more systems adopting wireless technologies. There are just so many systems nowadays that connect to IT network. It creates kind of its own challenge, because for IT teams, it's a big deal, starting with design of the physical network infrastructure and network architecture, to cybersecurity issues and protection of patient information and personal information. And all of these challenges are carried over to the implementation phase during construction, with addition of trying to manage 10 different low voltage vendors at one time, because there are just so many systems in the building. Like, it's a challenge.
Well, and I've got a question for you here in a minute about wearable technology. First, though, you had mentioned how you've got to attend webinars and try to stay on top of what's new and what's the latest in terms of this. Any trends or future developments that you're noticing in low voltage technology?
Well, we do always attend multiple conferences for educational purposes. And one of the big topics, for example, at BIXI conference this year was PoE lighting, power over Ethernet.
Okay.
I personally have not had a client yet, a healthcare client, who chose this option, mainly because of the high cost of this system and solution and somewhat lack of exact code that I mentioned earlier, because requirements are just not spelled out, and there's a big gray area in the design requirements. So I haven't seen it yet, but I think it could be very big in the near future. Just like we switched fluorescent lighting to LEDs, and no one really wanted them first, and they were very expensive, and now they're everywhere. So
now I was going to say, now everywhere's LED, right?
Exactly. So it could be something like that with PoE lighting, because sometimes product is developed and it's on the market, but it's just not right timing, not right audience, not right cost.
Yep.
And once exactly, and once it all comes together, it can just take over overnight. So that's something that I see can be pretty big. And what we also noticed, there is a big trend to try to consolidate multiple systems into a fewer number of devices that serve multiple systems. Because
some consolidation.
Exactly.
Okay.
Because there are just so many low voltage systems within the facility. As I mentioned earlier, like, for example, in a hospital, if you look at the ceiling, it looks like a Swiss cheese. Almost every ceiling tile has a device on it, whether it's like security camera or Wi-Fi antenna, radio antenna, paging speakers, RTLS sensors, motion detectors, smoke detectors, lights, you name it. What I see now is that some manufacturers, they started creating a partnership. For example, there is a lighting fixture now on the market that has built-in RTL. And lights is something that you put throughout the whole facility anyway. So why to have a light and RTLS sensors, two devices on the ceiling? Now you can purchase it all in one, and you have your lights and your RTLS, your real-time location system coverage in the whole entire facility. And it's all in one device. So I think it's pretty cool. But again, it takes a visionary, or it takes some needs from the facility to incorporate the solutions into their design. Of course, AI. So security cameras, for example, now have built-in artificial intelligence in them, right? They could be used, for example, for smoke detection. That would eliminate a separate smoke detector device. But again, there are just certain challenges with UL listing of how that device now is considered of the fire alarm system for life safety. And not all the cameras are UL listed for that purpose. So there is some licensing, there's some paperwork challenge there, but technology is there. It's out there. It's just now the matter of how to make it work all together and what the codes are. Yeah, there's some pretty cool trends out there.
And one of them that you mentioned before that I said we'd come back to is wearable technology. I know that's not brand new. It's been around for just a little bit here, but how does wearable technology, or where does wearable technology fit into the integration of technology in building systems? And you kind of touched on it, but there are some privacy and security concerns around wearables, and how are those addressed?
Well, wearable technology plays a pretty big role in building systems now. As a matter of fact, wearable technology is incorporated into a building code language now and is allowed to be used in place of some nurse call devices, for example. Also, it definitely benefits some systems like security, talking about like wireless panic buttons here that staff has on their badges. So it's basically a button that's built into their badge that they wear. It's always on them. It's convenient. And when the button is pressed, security officer knows exactly where they are, their locations, so they're able to provide help more efficiently in a timely manner to find them and provide that help to that staff. Or another example of wearable technology where we use our TLF tags for staff locating or for infant protection helps to integrate, for example, nurse call system with electronic medical record system for automatic charting and reporting. So it makes operations more efficient. So wearable technology is out there. It's been there for a pretty long time. It plays a big role in the building systems and facilities operations. Now, I don't see too many security concerns around it because typically there is no personal information attached to those technologies. They're just used for two-way communication or, as I mentioned, security purposes or security duress buttons or RTLS tracking. But what I do see is reporting and liability issues. So it becomes actually a legal issue because, for example, even with those panic buttons on the staff badges, nurses and staff and employees are given a device that they rely on during emergency. You have to make sure that device is working. You need to make sure that device is there for you during emergencies. So I see self-testing stations now added in the design because there's so many employees in the hospital, for example, who is going to test all those badges. So it's a self-testing station and it has automatic reporting system. So all the employees can, have a routine test. It's all reported. It's all recorded, so if God forbid something happens and you press that button and it doesn't work and something happens to you, whose fault is it? A manufacturer, a hospital, an employer? It becomes a legal issue more than, IT and information protection.
Let's talk a little bit about audiovisual systems for a moment. Can you share an overview of AV systems and how their applications in healthcare settings, as well as considerations that you make when designing and installing AV systems?
That's a good question, Brian. AV systems can be so different from hospital to hospital, from facility to facility, really just depending on their needs and program. The very simple example is, conference rooms and boardrooms. Almost every hospital has one for meetings and teleconferencing. That's simple. We live in the Zoom and Teams world now after COVID. Conference rooms, classrooms, and boardrooms are very common elements almost for every facility. Another example of AV systems are devices that are used for telemedicine, virtual nursing, virtual rounding, EICU, and even virtual visiting for families now that are more and more common for hospitals now. It makes it very convenient for family member who is busy, who is at work, who is in different state. It kind of triggered by COVID when no one was allowed in the hospital. No visitors, no family. Everybody was so isolated from each other. So this virtual FaceTime technology using cameras, microphones really kind of brought that family closer, and it expanded and still used because, why not? It's something that we adopted and it's working and it really benefits families and patients.
Right. You can still make that emotional connection even though you're not.
Yeah, you're closing that physical distance, with your FaceTime and technologies. So that was a great example that we adopted after COVID. Also, there is nursing education need that requires audiovisual devices to enhance nurses' education experience. We see anything from complex classroom setups and simulation labs with human mannequins to live video streaming from, for example, trauma rooms or from surgery rooms for educational purposes. They put observation cameras in the room and video display with sometimes even speakers and microphones in classrooms. So all the residents and students, they can, see what's going on in those rooms without physically being. So especially hospitals that focus on research and educational programs, they usually prioritize this type of AV systems and its application, and almost always include such systems in their facilities.
Interesting. What's the impact of AV systems on the patient experience then?
Oh, it can be major. If we look, for example, at specialized hospitals, like for children's, for example, That's where it gets
Yep.
very interesting. I absolutely love those projects. When I had them, it just gets so interesting. Children have different needs, not only for entertainment purposes, such as Xbox connection and patient room, right? Like to keep them
Right.
occupied, but
They got to play Fortnite, right?
exactly, but also for education purposes. There are classrooms for children who stay in the hospital for a long time. They can't leave the
Yeah.
hospital, they can't go to school, so they're being schooled there. So we incorporate AV systems like we see in regular schools into design for the hospital. Of course, the healing power, interactive displays, video walls, projectors that can create beautiful images on the floor, or a character that follows the child and, becomes a child companion really throughout his or her
Yeah.
journey in the hospital. I mean, that's huge. That's big. It can be a great distraction in a positive way for a child and even the whole family
Right.
altogether at the time when they're really dealing with health issues. With AV systems, you can make a whole storytelling if you want. You can make children calm and make them smile when they're sick, can bring them to a place as far as your imagination goes. Or I should say,
Yeah.
I should say as far as your project budget goes.
Right.
Because
But that is a big part of like you said, that's a big part of their care,
yeah,
right? Is
yeah,
not so much I mean, yes, it's a distraction, but in a good
in a
way.
good way.
So
Right. Like I said, in a positive way to get their minds off problems and issues. And the mental health is very important. You make people happy and your body seems to heal yourself better. It's where AV systems come and play, with all the interactions and displays and storytelling.
I'm going to switch gears a little bit. I know everything it feels like anyway, everything is based in the cloud right now, but I know that hardwired systems are important to the healthcare setting. So what are hardwired systems for our audience, and how do we address redundancy and fail-safe measures in hardwired systems?
Well, I have to tell you a secret, Brian. All communication systems are hardwired. All the wireless devices on the user end, like phones, our TLS tags, handheld radios, all the devices that we use and we think it's wireless, it just goes on the cloud nowhere. They're all connected to wireless antennas and devices,
that have to be
they
hardwired
have to be
somewhere, right?
hardwired, right? So it's just a network and a mesh network of wireless antennas that provide wireless coverage in the facility, and we just use those wireless devices for our convenience, and improve features and operations of the system. When we talk about hardwired systems, we really talk about all the systems. And plus, we also, of course, have, devices such as nurse call, security card readers, cameras, clocks, paging speakers that are typically hardwired either directly to the system's head end or directly to IT network for communication. Luckily, there are some building codes in place and other design guidelines that spell out the requirement for redundancy of the systems, such as communication service providers, pathways, and connections into the building have to have redundancy, or there is a requirement for secondary telecommunications equipment room in case if data center is remote from site. So, and that room would house all the redundant systems, head-end equipment, the network core switches, and other systems equipment, because both redundancy and system survivability requirements are a big part of the design. And we look very, very closely at the design in the whole engineering team at BSA. We always must ensure that systems that are critical to public life safety are up and running in the emergency situations and have backup all the time. And luckily, those requirements are backed up by codes.
You are so knowledgeable and you've got so much experience.
I
would love to
technical,
hear.
right?
No. I was going to say, with all this experience, can you share with me some of your favorite projects that you've worked on over your career? And do you have a favorite one? And what's your role been on those projects?
Oh, that's another very hard question. It's hard to point just one project as a favorite. I love them all, and for their own reasons. As I mentioned earlier, each project is unique and so interesting from the technology side large projects in particular, just in general, that's where I get my dose of oxytocin from. They're just great. Like with technology, it's a big deal. It's a big difference between doing large project versus small renovation or something, just lasts for 2-3 months and you just move on. So I'll give you a couple examples. I worked on a new hospital, MUSC Children's and Women's Pavilion in Charleston, South Carolina. I did design for Lee Health, Gulf Coast Medical Center campus expansion in Fort Myers, Florida. I worked on Joe DiMaggio Children's Hospital expansion in Hollywood in Florida. I've done many projects at Advent Health hospitals and facilities. The last one I did was the hospital expansion in Wesley Chapel in Florida. And currently I'm working on a new hospital design for Bakia here in Florida as well. And on a project of this size, it takes a very large team to complete the design, first of all. And when you have so many people and you have a long schedule, you build very close relationships with clients, other consultants, other firms, other professional teams, and your own teammates over that long period of time when you're working side by side. When you travel together, you see each other every day, whether it was in person before COVID and now in Teams or Zoom meetings, those long days of meetings and design and working side by side, it creates very, very close relationship. Needless to say, almost all large projects include pretty much every technology system. It gets very exciting, not only to design and deal with challenges of the project itself, like, renovations or expansions of the systems or some certain upgrades, but also you get to see after the project execution how technology solutions that you came up with really impact facilities operations or introduce brand new technology to users or increase patient satisfaction and family experience. That brings me back to your original questions about post-occupancy evaluation. That's where it gets even more exciting because it's so unique to that facility and the project, and you worked so hard for so long, you can really see how it changes lives of
the impact.
Exactly. The operations, the lives of nurses and staff and physicians, doctors, family, patients, everyone. That's huge. So I love them all.
Well, your passion certainly comes through. And for my last question, I guess, is kind of, again, geared towards the future. Is there anything that you're noticing or anticipating for technology in the future in healthcare space as it pertains to engineering?
Artificial intelligence is something that everyone is talking about it right now, right? And there is a good reason for it. Let's look at evolution of technology and communication system. First, we can see that the system itself would go through major changes. For example, when we switched from analog phone lines and operators to voice over IP phones, then systems started to get more and more advanced and complex and have more and more enhanced features. We added wireless technologies, but we still looked at the system as individual system design. And as we talked about earlier, then we started to integrate those individual systems into complete, full technology solution, looking at the bigger picture, taking in consideration facilities, needs, and desired function as a whole. Now that systems are able to talk to each other, more and more devices are connected together. Those devices are getting smarter and smarter every day. We are able to collect and transfer automatically very, very large amount of data. But we're still facing that challenge, which is extracting the truly meaningful data that is beneficial and useful from that big data. For example, for record keeping and reporting. At the same time, while we are still trying to optimize data storage and protect personal information. Think AI solutions are something that can be definitely incorporated in the design in a very near future.
Yeah, I think that's something everybody's looking at, right?
Yep.
Whether it's in architecture, engineering, in marketing, we're looking at it. I know in finance and human resources. So it sounds easy when we ask these future-driven questions for everybody to answer AI, but I think it just reiterates the point of how impactful this is going to be.
That's right. AI is definitely on the rise.
Well, I want to thank you for coming on. This has been such a wonderful conversation, wide-ranging topics, and hope to have you on again in the show soon.
Thank you. Thank you for having me, Brian.
Thanks again to Marija for joining us on this episode of BSA by Design. As I said at the top of the show, a really interesting conversation that spanned around a lot of different areas. If you're interested in learning more about technology and our engineering services at BSA Life Structures, we encourage you to visit our website at bsalifestructures.com. There's a link in the show notes to contact us for more information and a link to our engineering page. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. And we've got more content to share through social media, so be sure to follow us on LinkedIn, YouTube, Facebook, Instagram, and X. That's going to do it for this episode. Join us again next time on BSA by Design.